In this video we're going to build a heat map using Django and Plotly, and this heat map is going to replicate the GitHub contribution heat map. Every developer who uses GitHub is probably familiar with this heat map. We're going to see how to build a very basic system that replicates that with users, commits and repositories. And then we're going to generate some random data and use that data to generate this heat map using Django and Plotly. Now starter code is available on GitHub. The link is in the description. So let's get started and we're going to see how to build this heat map. And what we're going to do is we're going to create a couple of models. We're going to link the user model in Django to a commit, and we're going to link commits to a repository, and that can kind of mimic what GitHub do. So what we're going to do to start with is we're going to go to our VS Code here and we're going to install the requirements, and you see that we have Django, Django extensions, Django model utils and Plotly. And you can install those with the pip install -r requirements.txt command, and that'll install them into your virtual environment. Now once we've done that, what we're going to do is we're going to build the models for this application. Now we mentioned that we're going to link a user to a commit and a commit to a repository. So we're definitely going to need Django's built-in user model, so we're going to import that at the top. And once we've imported that, we're going to create a repository class, and that's our first model, so we'll inherit from Django's models.model. Now to replicate what GitHub have, we're going to create a name for this repository, so it's going to be a models.char field, and we'll give that a max length of 255. Secondly, a repository should belong to a user, so we're going to create a foreign key to the Django user object, so it's a models.foreign key to the user, and when the user is deleted, we want to cascade that and also delete the repository as well. And finally, we'll give the repository a stars field as well. That's going to be a positive integer field, and it will default to 0 when a repository is first created. And the final thing we're going to do for this class is just create a dunder string method that will return the name of the repository. And once we've done that, we can then create the second class, and this is the only other class we're going to use, and it's going to be a commit class, and that will also inherit from models.model. And for now, let's pass on this class here. One thing I've forgotten to do with the repository is we want to indicate when this has been created. So what we're going to do is we're going to use something from Django model utils. This is a package that you can use in your Django applications. And we're going to use this here. It's the time-stamped model, which is an abstract base class that provides self-updating created and modified fields. We need to use that to have a created field. So what we're going to do is at the top, we're going to import time-stamped model from Django model utils, and then instead of inheriting from models.model, we're going to inherit from that abstract class, and that's going to add a created and modified field to the repository, so we'll know when the repository has been created. And we're also going to inherit from the time-stamped model in our commit class. So when we make a commit, we'll know when it was created. And that's going to be important later on, because obviously when we make this heat map here, as you can see on GitHub, we need to know when the commits have been made. So let's now build the commit model. First of all, we're going to create another foreign key to the user. So when a commit is made, we need to know which user has made that commit. And when we delete the user, we want to change this to models.doNothing. And that makes sense because when a project has commits, even if the user deletes their profile, you want to preserve the commits for that project. So we're not going to cascade, we're going to do nothing. And let's also give this a related name of commits. And that way we can easily reference all of our users' commits from user.commits.all. Now we're going to add a second foreign key here. A commit belongs to a repository, so let's add a foreign key to the repository model that we've created on line 6. And we're also going to add a code field. Now this is not going to be anything sophisticated, it's just going to be a text field so that each commit has a piece of code attached to it. That's not the way GitHub works, but we're creating a very simple version of GitHub here. Now the final field we're going to add is the hash field. Now that's going to be a models.char field, and we'll give it a max length of 40. Now when you create a commit using Git, there is a hash attached to that, and I can look at the log for this here and you can see that there are commits for this repository and each one has a commit hash. We're going to replicate that now, and we're going to store that in a hash field on the commit model. And to finish off the models, let's create a dunder string method that returns the commit hash, as you can see here, commit and then the hash. So what we're going to do in order to create this hash, when we make a commit, we're going to automatically call a function that's going to generate a SHA-1 hash. So let's start by creating a utils.py file, and this is going to store a few utility functions in this tutorial. And within this file, we're going to import 3 modules from Python's standard library: the hashlib module, the random module, and the string module. And what we're going to do is write a function called generate hash that is going to generate a hash for us when we make a commit. So what we're going to start by doing is generating a random string, which we'll call hash string, and it's going to be equal to an empty string.join, and to that we're going to use the random module's choices function, and we're going to get 6 random ASCII characters. So we're going to use the string.ASCII letters, that's a variable on the string module, and we're going to pass k equals 6, and that will give us back 6 random ASCII letters, which we then join into a single string using the join function. Once we've done that, we can pass that random string to the hashlib's SHA-1 function. Now the hashlib module is built into Python, as you can see here, and it provides a number of hashing algorithms for you to use. And one of them is this SHA-1 function that generates a SHA-1 hash. And we're going to use that here, so let's go back to VS Code, and we're going to return hashlib.SHA-1, and to that function we pass the hash string that we generated above, and we need to encode that. And then that will return an object which we can then call hex_digest, and that will give us back a hash. And we can see this below if we go to the Python shell and we copy this code down to the terminal. If we call that generate hash function, we then get back a hash object, and every time we call that we'll get a new hash object back. So that's the purpose of that function. We can exit the shell now, and we can then go back to our models.py, and what we're going to do is import this function here, and we're going to make that the default for this hash field on the commit model. So let's go to the top and we can import the utils module that we've just created, and then in the hash field here we're going to pass a default argument. And Django models, you can actually pass a callable as the default. So we're going to reference the utils module's generate hash function. Now it's important that you don't call the function, you just reference it, and then every time a new commit is made, if you don't pass the hash to that, it's going to automatically generate it by calling this function. So now that we've done that, let's make the migrations that we've got here from these models. That will create the 2 new models and create migration files for them, and then we can call the python manage.py migrate command to actually generate the tables. We're now going to add these to the admin interface, so at the top of the admin.py file we'll import the 2 models, and then we can register these models below with the admin.site.register function. Once we've done that, we can then create a super user with the python manage.py create super user command. We'll call the super user admin, and we'll give it a password of test. We can now run the server, so it's going to be python manage.py run server, and then we're going to go to the admin interface and access the admin with this new admin user. So if we go to the admin interface, there's a login form, we can log in with that new user, and we now have access to a commit and a repository model. You can see the plural version of repository is incorrect. We can actually fix this in the model class. So if we go to the repository model, we can create a meta class here, and there's a field called verbose name plural which we'll set to repositories, and that will fix this pluralization issue here. What we're now going to do is create a repository, so we'll go to that page here, add repository, and we're going to call this repository the next Facebook, and we'll attach that to this admin user that we've created, and then we can save that, and that will appear on the list page. We can now create a commit, and you can see that we can tie that commit to a user and also to a repository. The code, we will print hello, and below that there's a final field, the hash field, and importantly you see that that has been automatically generated. So we can save this and we can choose to add another one, and the hash has changed, so we can get a new hash each time we create a commit. And we can see the fields that have been added by the time-stamped model. If we stop the server here and we go to the Django shell, so it's python manage.py, and we'll use shell plus from Django extensions. We can call the repository.objects.first command, and that will give us back that repository we created in the admin, and it has a field called created, which is a datetime object telling us when the repository was created, and that's added automatically by the Django model utils timestamped model. And that also adds a modified field as well, which will tell you when the repository was last changed, and these are automatically updated when anything changes, which is quite cool. So that's a lot of the setup out of the way. What the actual goal is for a given user, we need to fetch all of their commits. So to do that, we can use the user.objects.first command, and that's going to get us back the first user in the database. We'll store that in a user object, and we see that admin user that we created earlier. To get that user's commits, we use the user.commits.all function. And you can see there's only one commit obviously, but we get that back and that's there. And that's how we access all the commits for a given user. And you might want to order these by the created field. So order by and then pass created to that. And that will give us back all of the commits ordered from the first one up to the last one. Now what we want to do is build a heat map that's similar to what you see here on GitHub. So what we're going to do is we're going to generate historical data using a management command. This is just going to be fake data that we're going to use to build this heat map. So if we go back to VS Code, there's a management folder, and within that there is also a commands folder. So what we're going to do is create a new command here called generate commits.py, and I'm going to paste some code in here, and we'll quickly walk through this code just now. So let's go to the top here. We have a bunch of imports, and what we're going to do is we're going to get the first user in the database, and for that user we're going to create a repository and link that repository to the user. And you can see also that we create a couple of datetime objects, one for the current time, that's called now, and one for the previous year, which is generated by looking at the current time and subtracting a time delta of 52 weeks. So once we create the repository, we also now have to create the commits. So we clear out the existing commits from the database, and then we loop over each day from the start date, which is the previous year, up to the current date. And for each day, with probability of 0.5, we're going to generate some commits, as you can see below. So it's going to be any number from 1 to 10 commits on a given day. And you can see on line 43 that we create a commit object, and we loop over whatever the random number between 1 and 10 is to get that number of commits for that day. And if the random.uniform call on line 37 returns a number below 0.5, we don't have any commits, we just continue. So some days we'll have no commits, other days we'll have any number between 1 and 10 commits. And that can kind of simulate a real life scenario. Now this file will be available on GitHub, I'll link it in the description. Once you've created that file, you can run the command python manage.py generate commits, and that will run through this file and it will generate a bunch of commits. And we can verify by going to the shell, and then we can run the command commit.objects.count, and you see that that's generated 1042 commits. So now that we have commits, let's start building this heat map. So what we're going to do is add a URL to our urls.py. Let's first import the views, and then within the URL patterns we're going to add another route. So we use the path function, and we're going to create a view called commits here. So let's go to views.py and we'll create that view now. It will take the request as an argument. And what we're going to do is we're going to fetch all of the commits from the current user. So it's going to be commit.objects.filter, and we'll filter the commits down to only those made by the current user. And then we'll order those using the order by function, and we'll pass the created field, and that will order by the created field. Now we also need to import from the models file the commit model, so we're using that commit model, we need to import it. And because this function relies on there being a user, we're also going to import from Django the login required decorator, and then we can protect this view using login required, so it's only accessible to logged in users. And once we've got the commits, we are now going to create a context which will initially be empty, and then we'll return a template called commits.html. And you can see that that exists on the left hand side. It's currently empty, it's got an empty content block. We're going to fill that out in a second. But what we're first going to do is we're going to create a function that returns all days in the last year, from the start date up to the end date. So we're going to go to utils.py to do that, and we're going to import from django.utils the time zone module. So let's define a function now called dateRange. It's going to take a start date and an end date. And what we're going to do is create a delta object, and we take the end date and we subtract the start date, and that's going to give us the delta between the end and the start date. We'll then create an empty dates list, and then we're going to iterate for I in range, and we'll pass delta.days. Now time deltas in Python, they have a days attribute, and that will give you the number of days between the end date and the start date. Because we are working with GitHub, we want this to be 1 year, so when we pass in the start date and the end date, it's going to be over the past year. And then we iterate over the number of days between the two dates, and then we're going to append a new date object to that dates list there. And the object is going to be the start date plus a timezone.time delta, and we'll set the number of days equal to the I variable that we're looping over, as you can see here. And finally, we'll return that list of all dates between the start date and the end date. Now this will work because it will figure out how many days are between the two dates, and then we'll iterate over that range, and then we add a time delta to the start date with the current number that we're iterating over, and that will give us all days between the start date and the end date. So now that we have that, let's go back to views.py, and at the top here we're going to import the time zone module. And what we're going to do is, in the view, we're going to generate a start date and an end date. Now we'll call the end date now, and it's just going to be timezone.now. So that'll be whatever the current time is when this view is called. Now we want to go back a full year for our GitHub heat map. So we're going to generate a start time, and it's going to be equal to now minus a time delta with 364 days. That's going to go back a full year, and we're going to use that as our start date. So now that we have the start date, which is a year ago, and the current time, we're going to import the utils module, and we're going to call this function here called dateRange to get all dates, or rather all days between the two dates. So let's create a variable called dateRange, and we'll call utils.dateRange, and we pass the start date and now to that, and that will give us all of those days between those dates. So what we actually want to do for each day in this range of dates, we want to find out how many commits were made on that day. So what we're going to do is create an empty list here for the counts, and then we can iterate for dt in dateRange, and that will iterate over all of the dates in that range. And we can then filter the query set of commits by that particular day in order to find out what number of commits were made on that day. So we'll create a variable called count, and it's going to be equal to commits.filter, and we're going to look at the created field on the commit model, and then we can use the date lookup here and set that equal to the dt object. So for each date in this date range, we're going to look up the commits that we fetched on line 10 here, and we're going to filter them down to only the commits that were made on the given date. And once we've filtered that down, we can use the orms.count function to get the number of commits on that day. And when we find the number, we can finally append to the empty counts list the count for the given day. And so what that's going to do is, for each day in our date range, we're going to append a number for that particular day with the number of commits made on the day. And in order to see this better, we can print the number of counts out to the terminal. So when we call the view, we'll be able to see that. So let's run the Django server here, and we're going to go to this URL that we created. It's the commits endpoint. If we go to Chrome and we go back to the application here, we can then go to /commits, and we should be able to see in the terminal the number of counts for the given user. Now you can see the page is empty because our template doesn't contain anything, but if we go back here, we have a list of numbers, and that's the number of commits for each day, and that's what we're going to use in order to generate this heat map. So at this stage, we need to have a look at the Plotly documentation for heat maps. We can look at this page here, which I'll link in the description, heat maps in Python, and you can see here there's a function in Plotly Express called imshow, and that's used to generate these heat map style visualizations. And to imshow, you pass a two-dimensional list, and that's exactly what we need to do, because what we need here, if we look at GitHub, is we need a two-dimensional data structure with rows and columns. The rows represent a given day of the week, and the columns represent a given week. So there's 7 days in a week, so we have 7 rows with 52 columns, one for each week in the year. So we need to replicate this. We need to build a two-dimensional list that we can then pass to the Plotly Express imshow function. So what we're going to have to do is we're going to modify in our views.py file, we're going to modify this counts. We can't have a single list with 364 numbers. We need a 7 by 52 list. So I'm going to stop the server right now, and I'm going to go to the Python shell, and I'm going to show a trick that you can use to generate a list that has 7 inner lists. That's what we're going to do in a second. So we can do this by using a list comprehension. So we'll define square brackets here, and within the list comprehension we want to generate an empty list, and we need 7 of those. So we do that for I in range 7. And if we look at the result of that, you see that we have a list that contains 7 inner lists, and that's exactly what we need. Each inner list will have the numbers for a given day of the week: Monday, Tuesday, Wednesday, Thursday, and so on. So we need to copy this statement here, and we're going to copy that into our view. On line 14, we defined the counts. We're going to replace that with this statement here. And we're also going to define a dates object as well, which is going to be equal to the same statement. So we have 2 lists that each contain 7 inner lists. Now it's important to note that you could use NumPy for this. If you have a list with 364 elements, you could use the reshape function in NumPy to reshape that to whatever makes sense for your application, in this case 7×52. But we're going to stick to the Python standard library in this tutorial, so we are going to use this syntax, and then we need to modify the for loop below. So what we're going to do in the for loop, we're going to reference the weekday. Now, Python datetime objects have a weekday function that gives you a number between 0 and 6 for the day of the week. And that's exactly what we need here. We have 7 lists within that parent list, and each one of those has an index 0 up to 6. So the weekday is going to tell us which one of these we want to append a count to. Now, to demonstrate this, I'm going to go to the shell plus, and I'm going to import from core.utils that function dateRange that we made earlier. And we can copy now and start into the terminal, and that's going to allow us to generate all dates between those two dates. So if we paste those in, we can then call the dateRange function, pass the start date and now to that, and that will give us back a range of dates. If we inspect that range, you see we have a list here. If I look at the first element in that list, we have a datetime object, and if we call the .weekday function, it gives us back a number between 0 and 6. So we want to use this weekday function in our view in order to find out which list within our parent list that we want to index into. So in line 17, just below that, I'm going to create a variable called day number, and it's going to be equal to the date that we're iterating over in the for loop, and we'll call the .weekday function. And then rather than appending to the counts list directly, we are going to append at the correct index by referencing that day number there. So that will be a number between 0 and 6, and that will then place the count within the correct number for that weekday, or rather in the correct list for that weekday. And we're also going to append to the dates list here the correct date, so we'll index in at the day number, and then we'll append the date object that we're working with. So if we now hit this view, and I'm going to run the server and go to this view, when we print out the counts, we should see a 2-dimensional data structure. So let's go back to the page and refresh this here, and when we go back to the terminal, you should then see, once it's finished processing, we have a 2D list, and you can see the last element of that list here. So that appears to have worked. We have now a 2-dimensional list, and each inner list represents a particular day of the week. And if we look at GitHub, that's going to be used to generate the rows for our heat map. Now at this point, we're actually ready to generate the heat map. So if we go to the Plotly documentation, you can copy this import of Plotly Express, and we'll add that to our views.py file at the top here. And if we go back down here underneath this for loop where we generate the counts, we are going to create a figure object, and we're going to reference the px.imshow function. To that, we pass the counts that we've generated here on line 16 and within the for loop, and that's the 2D list of counts. We can then generate the chart's HTML by calling the figure.toHTML function, and then we can add that chart object to our context, as you can see here, with a key of chart. And then if we go back to our template here, we can then reference this chart using the Django template syntax, and we need to mark that HTML as safe to directly render using the safe filter. Now if we save that and go back to the page here, this is our previously empty page, hopefully we'll now see a heat map that we can then customize to make look more like the GitHub heat map. And once that finishes processing, you see something like this. This is not the color map that we want to use or the color scale that we want to use, so we're going to change that in a second. We're going to customize this so that it looks a bit more like the GitHub heat map. But the important thing to note is that this has actually worked. It's generated a heat map with the right number of rows and columns for our GitHub contribution graph. Now what we're going to do now is change the color map. If you go to Plotly's documentation, there is a page here for color scales in Python, which will be linked in the description. We want to use a sequential color scale, and the one we're interested in that looks quite similar to GitHub in my opinion is the greens color map. And you can see those colors here. What we're going to do is we're going to reference that in our view. So what we can do is go back to the view, and we're going to look at this function call here to imshow. That's what generates the heat map. And there's another keyword argument that we're going to pass to this function. And that keyword argument is the color continuous scale, and we're going to set that equal to greens. So if we save this file and go back to the page and refresh, we should now see hopefully that the heat map looks a bit more similar to GitHub's in terms of the colors being used. And that is slightly better, but we are going to customize this even more to look more like GitHub. But the colors are a little bit better. The darker the color, the more commits have been made on a particular day. Now this isn't a perfect replication of this here, but it works quite well, and we're going to stick with the greens color map, but you're free to customize that if you want. And you can reference this page here for all the color maps and scales that are available in Plotly. Now what we're going to do now is add some axis information. So you can see that there are months along the axis at the top and days of the week on the rows. We're going to try and replicate that a little bit by adding some more keyword arguments to this Plotly imshow function. So the X parameter I'm going to set equal to the dates object, and we're going to index into the first row of that inner list here. What that's going to do, if we save the file and go back to the page, at the bottom along the x-axis at the moment you see a bunch of numbers. That represents each number of rows. If we refresh that after adding that x parameter, you see we now have the months. We have actual representation of what date should be along those columns. And that's important. It gives the user a little bit more information about what dates we are actually looking at along these columns. Now we're going to do something similar to the rows, which are just currently numbered. Remember, each row represents a day of the week. So what we're going to do is we're going to, at the top, import the calendar module. This is from Python's standard library. And if we go to the Django shell for a second, and I'm going to import the calendar module here, there's an attribute in the calendar module called dayname. And what you can do is you can actually pass that to the list function, and that will give you back each of the days of the week. And we're going to use that in our view in order to generate the y-axis labels. So what we're going to do, just here above the figure, we're going to create a list of day names, and we'll call that day names. And we can then pass these as a y parameter to our Plotly imshow function. So we'll pass y equals day names. And if we run the server again and go back to the page, we should hopefully see that the y-axis labels now represent the day names. And you can see that that's worked on the left hand side, but we might not be referencing the correct first day. So remember, we're looking back a full year, 364 days, and the first day might not actually be Monday. So how do we find out the first day? We're going to write some code to do that just now. So let's create a variable here called first day, and we're going to look at this date range here, and we're going to get the very first day by indexing in at element 0, and then we can call the .weekday function. This will give us back a number between 0 and 6 for the day of the week. What we can then do is we can index into the day names and we can get the correct order of days. So let's create a new line here, and we're going to say days is equal to the day names, and we'll reference the day names from the first day up to the end of the list, and then to that we can add day names and we'll reference all elements up to the first day. Remember, first day is a number, so we'll take that number, for example 2, and we will go to the end of the list. So if the first day of the week is the second day, which I think is Wednesday, remembering of course that it's 0 indexed, then that will give us all days from Wednesday to Sunday, and then we can add to that all days up until, but not including the second element. So that would give us the Monday and Tuesday at the end of the list. So I hope that makes sense. We can then reference these days instead of day names below. And this is just some clever indexing that we can use in order to take this list of day names and put them in the correct order based on whatever the first day was. So if you save that and go back to the page, we can refresh and we'll now see the order will change unless your first day was already Monday. And you can see that I'm recording this on a Saturday, so that's the first day of the week if we look back a full year. So our heat map begins on a Saturday and it ends on a Friday. Now the last thing I want to do in this video to make it look a bit more like GitHub, we're going to change the width and the height, and then we're going to also give it some padding. So let's see how to do that. If we go back to the Plotly imshow function here, we can also pass height and width parameters. So I'm going to set the height equal to 320 and the width equal to 1300. Now you can play around with these numbers if you want, but if we do that and then save, we should now see that the dimensions change on this heat map. And we get this back here once that's finished. It looks a little bit smaller, and that's probably what we want here. Now, as well as changing the width and the height, I want to also give a little bit of padding between each cell. So what we're going to do is we're going to call a function called the update traces function. This is a function on our figure object, and we pass an x gap and a y gap to that, and I'm going to set those equal to 5. Again, you can play around with those numbers, but when we refresh this, we should see that there's some gap between the cells now in our heat map, and that looks a little bit more like GitHub's. What we also want to do is change the background color to white, and there's another function that we can use here just above figure.update traces. There's an update layout function, and we can set the plot's background color to white using that function, and then we can refresh this page and hopefully we'll see the grey disappear. And this looks fairly similar to GitHub. It's not perfect by any means, but it's quite similar. You can play around with the colors and define custom color scales if you want, but I think this is similar enough for this video. This is how you build a very basic replication of what GitHub does. We have a repository, we have commits, and we've got this data here. Each user has a number of commits for a given day, and then we have a commits function here which will take care of rendering a Plotly heat map. Now, one thing you might want to do is break this view up into some smaller functions because it is quite long, but that's up to you. For this tutorial, we'll leave it as it is. Thank you for watching this video. If you've enjoyed the video, please like and subscribe to the channel and check us out on Twitter, and we'll see you in the next video.